Welcome to module 6 lecture, that is 6th week lectures. We are continuing with design of general purpose industrial helical gear reduction unit, and this is part 4, and we are in the last phase of that. Last time we have shown the complete assembly view, although it is not complete in the full form, but main plan view, elevation and side view are completed, and now we shall go for detailed drawing of the components. Now, it is not possible to make all the detailed drawings and shown it to you, although it is possible we can make the drawings, but within the scope it is not possible. So, I shall show you details of on sample, and in that way I would say the intermediate shaft is the best one. So, what I am doing, I am showing the details of intermediate shaft and first stage gear. So, in this lecture, first of all we shall recapitulate the developed plan, elevation and side views of the reduction gear unit, and then detailed drawing of intermediate shaft, and including that will include the integral second stage pinion, and finally, detailed drawing of first stage gear. Now, this is the total view of the gearbox. It is not fully completed, but still you can find that in the top left hand corner is the plan view, and bottom left hand is the elevation, and bottom right hand side is the side view. This we have actually planned in such a way, we have developed this is in A0 size sheet, the maximum size sheet available, and somehow we could accommodate all the views there, all keeping a less space for writing the nameplate and other, but still it is possible that we can accommodate there. It is always better if you can present something in 1:1 scale. And we have followed third angle projection. You know what is third angle projections. If you look into this, that the icon is given here. So, we have followed, if this is one view, the top view, you can say top view or side view from this side will be this one. We are not following there. So, we can put a cross over there, and scale we have taken 1:1, and a typical drawing on printing, as you can see this drawing sheet, it will be something like that, and it is available in the industry. This means that you can develop the drawing in AutoCAD, and then that you can copy on a drawing sheet in proper place, and then it can be printed. So, that is shown here, the typical drawing, it will look something like that. Now, in the plan view, if we look into this plan view, then this is the input shaft, right hand side input shaft, and then intermediate shaft, and then output shaft. And we have also, I have also given the overall dimensions. It is somewhat coming 635 millimeter long, and width is not much, 210. With bottom base it will be slightly more, which we can see later in the complete drawing. But this is a very small size gearbox. If you calculate the power with nominal torque, it is about 2.5, 2.753 kilowatt, and as there is 200% starting torque, maybe we can select a little higher size motor, but this is really a small size gearbox. Okay. And here, although I have mentioned earlier, but still I would like to mention that important is that you can see this dowel pin here. Here is the dowel pin, okay, and the other corner also dowel pin is there. Two dowel pins are put, so that we can put the top cover properly. And if you look into the bolting arrangement, then we will find there are many bolts. Apparently, these are placed about 50 millimeter, here it is a little more 65 millimeter or so, 50 millimeter, and near the bearing we have put large size bolt. We will put here M10 bolt. Okay. So, this will be good enough for taking all bearing loads, and we have kept this bolt size, this M10 bolt size of equal size we can put. So, totally required 12 numbers of such bolt, nuts, washer, etc., etc. And another issue I would like to mention here, that when we are putting these two covers and we are tightening fully, but still there is a possibility of leakage through that. So, to prevent that, sometimes a very thin material like a transparent sheet is put there, which practically has no dimension, you can say, after the pressure is put, after the bolt are tightened. And alternatively, some glue type materials also can be given, that so that it will prevent. There is a rare possibility that oil will leakage through that and dust will go inside through this. And as you see this input and output, there are, although it is not shown here, but I have shown that we can use the oil seal. We have to use the oil seal, so that oil cannot go out and dust cannot come in from the outside. Now, here the details of intermediate shaft, we will make now the details of intermediate shaft. Why the details of intermediate shaft? Because the intermediate shaft has no output or input, right. So, if we can make these with proper dimension and other things, it will be always to make the other two shafts drawing easy. And when we developed the plan view, then we have put one after another and we have taken the dimensions accordingly. But you will find while we further making the detailed drawing, still some dimension can be altered, and then finally, that can be put into final assembly drawing. That will not be much laborious, because already it is developed with a little manipulation in the AutoCAD, this can be managed. Okay. So, in this intermediate shaft, what we find, that there is the integral pinion is here, okay, integral pinion. So, this is the integral pinion with the shaft, and this bearing is loaded with higher radial loads, because as this pinion is close to this bearing. On the other hand, if we look into other side bearing, that will be less radial load, and then we have locked this bearing fully with housing and shaft. How we have done it? On the housing, we have kept some ridge portion in the boring. So, this inner race, left side of the outer race can rest on that, and other side is tightened by the cover. This is the cover, and again I mentioned that here maybe a thin gasket can be put there to prevent the leakages. Now, with the shaft, how we have locked the bearing? First of all, a spacer is required to connect the gear with the inner race of the bearing, okay. And then it can be locked on the shaft by a circlip, simple circlip, but here we have used a lock nut and washer just to show. Normally, this lock nut and washers are used with taper roller bearing, but no harm that we can use this with that one. Of course, for using such things, we have to make a thread on the shafts and cost will be little higher than if we try to lock it with the circlip. Other ways also there, you can simply put a plate here, and on the plate and shaft you can put 2 bolts, and that bolts can be locked. So, that can be locked with shaft. Okay. So, we have locked this side so that irrespective of the direction of rotation with an assigned helix angle, the axial load always will be taken by this bearing. Okay. Now, we shall make the detailed drawing of the shaft. I shall mention later of course, but here one interesting part is that while we are putting the gear on the shaft, first of all it should be tight fit. It might be light drive fit, by no means it should be running fit or loose fit. And then if we think of this spacer which is connecting the gear side with the inner race, to confirm that these will touch both the gear and the inner race without any interference anywhere, what we do, the step on the shaft is less than this. Suppose this is B 2. So, this will be say L 2. So, it will be L 2 is less than B 2. That means, here it is a step down, maybe by just by 1 millimeter from here. Okay. Say D bearing and D S, then D S might be simply D B by 0.5 millimeter. So, that this spacer can be put, and this finishing here and finishing here may not be the same, it is not required at all, and we do not have to drive the long way. So, for that, this always when we are developing the detailed drawing, that we have to keep in mind. Okay. And there are also undercut needed to be provided wherever the bearing is touching with the shoulder or anything touching with the other component, that we have to keep in mind. We have to judge where to put the undercut. Now, very quickly we shall go through this gear data, because in this intermediate shaft this pinion is integral. Say this pinion, we will need this data, the second stage pinion, and this information will be there, and then it is this module, then the helix angle, then this direction of that module, this, and next we will need that what is the pitch circle diameter. We will need this one, the pinion, this is the pitch circle diameter, and this center distance already is there. We need to have the tip circle diameter. Root circle diameter is not given on the drawing, because this gear data is to be provided with the detailed drawing of the gear or pinion. So, with the intermediate shaft, all these data will be provided for the manufacturing purpose. Okay. And face width 68 millimeter, material, and these all this specification, these two are not required for the development of the drawing. However, we have to furnish there, because we have to also furnish the information about the heat treatment there. Okay. Now, this is the detailed drawing of the shaft, this intermediate shaft. This I shall come into details of that, but you can see this was the drawing here, and this we have developed here. But if you closely observe, you will find here we kept a diameter is more, but because initially we took this bearing of, we took 6309 45 millimeter, later we have changed it to 208, that means here it is 40 millimeter. So, here perhaps we can reduce the diameter, so that here at this, here we get more space, more shoulder, shoulder, so that it can touch it, we can have more area for the thrust. So, this diameter we are reducing. Okay. So, in the detailed drawing we have accommodated that, and as you find we have kept here many notes. By no means this is not the complete drawing, we still need more information on this drawing, but how we are developing this one, that I will show. This is very important to know this. So, what we have for this detailed drawing, what we have done, we have taken A3 size drawing sheet, because if we take the A3 size, say this is the size of the drawing sheets, and we can put this drawing is 1:1 scale, that is again better, and we do not need larger side view, other things. So, A3 size drawing sheet if we use for all component drawings, that we can, this is for documentation, everything it will be very good. Of course, for the detailing of the housing, perhaps we have to go for large size drawing sheet. These are minor issues, but still we can remember. Now, the scale 1:1, and again third angle projection we have followed. Now, here I have shown the detailed drawing of this intermediate shaft. Now, I shall explain one after another how this is being developed, and it is not easy. Even if I explain twice, thrice, it is not possible that one can learn it in just a single instruction. He has to follow, he has to remember many things. One important issue is that while we are making the development of such detailed drawing or making the detailed drawing, we should have idea about the manufacturing, how will you manufacture. Now, first of all, let us consider we have to make only a single piece. Okay. This is just a job order type single piece. Okay. In that case, what we need to do, we should first of all, what would be the length of this shaft. Here after the detailed drawing development, what we find, this is 220 millimeter long, and here the maximum diameter is 73 millimeter. So, probably if it is a good stock, if it is available of 75 millimeter, that will do. 75 millimeter EN 19, this bar is available in the market. So, buy one, buy a piece of 220, not you have to make a little, you have to buy a little larger, maybe 230 or 240, maximum you can say 10 inches, 250 millimeter, and 70, if it is a good one, 75 millimeter will do, or else you can go for higher size. Probably next size will be, higher size will be 80 millimeter, easily available. In between that it might be there. Okay. So, you buy say maybe 10 inch, buy a 3 or 3/4 inch a bar. Okay. But if it is not that, if we go for mass production, then probably we can buy this bar of say 200 millimeter length and probably diameter may be 75 or even less, 70 millimeter, and then by forging we can, if we go for forging, in that case we keeping this on forging material can be made like this. So, this is after forged. Maybe the bar size is 5, say 68 millimeter, even less than that, notice it, and length may be of just 200 millimeter. So, in mass production you can cut the pieces like that, and by forging you can increase here and you can decrease a little bit there, and you can make keeping the material for machining say 3 millimeter everywhere. So, we can make it like that. Okay. Next we shall think of the machining. Now, in machining usually these are if it is a single piece, then of course, we can held it in a chuck, its length is slightly more, and just by supporting it some means, it is a small one, we can machine it, heavy machine it is possible, but it is always preferred that we machine it with putting into two centers. It one side it might be dogtail and other side the tool post, or else this is one side is fixed to the chuck, other side is a tool post, and tool post is holding this shaft while machining. For that we need center hole. The special tools are there by which we can make a center hole. Even we can make this piece machine in maybe in some other very rough cutting machines, say 225 millimeter long with center, or maybe 222 or 223 with this center hole. We can take this piece and then we can put another lathe for final machining. Now, while we will machine that, then a designer may be tempted to give the dimension here, 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 because he need the lengths for gear fixing, say it is about 68 millimeter, we have this 68 millimeter. So, we need 60 millimeter here, the spacer is 15 millimeter. So, 15 millimeter here, bearing is 18 millimeter, 18 millimeter here. So, we can put the dimension like this, but in that case while the machining will be done, the operator, the machine man, he has to add this thing to calculate the dimensions and then will do. So, a good designer, a good say detail drawing, particularly if it is a precision industry or if it is a aircraft industry or so, you will find that in that case there are designer, he is making a drawing, and then the manufacturing engineer, he is making a that he is modifying that drawing before handing over it to the machine man. But in that way, if you see what are the important dimensions here, first of all 220 that you have to keep in mind. Then first we will consider that here the bearing will sit, for which the width, if you can remember, that 18 millimeter width, and after that we will make this lock nut, and lock nut thickness is from the catalog it can be changed, it is only 7-8 millimeter. Okay. So, maybe totally if you keep including the washer, it will be 10 millimeter maximum, okay, of this size shaft. So, maybe keeping at 14 or even 12 millimeter will be okay, but that washer it should touch the bearing, keeping that this portion should be less than the bearing width. So, what we have done, we have taken 30 millimeter from here to here, and for thread we have kept 14 millimeter. So, that this space is 16 millimeter and we are sure that will touch into the bearing. Okay. So, that is done. Next we have to think of that it will be for the spacer, we will put the spacer. So, what we will do, we will take, we have measured and keeping this space for gearing a lace, it is already calculated, design engineer he has calculated and he has put this dimension 52 of 42 diameter, and then this space for putting the gear and there as you find the diameter is with tolerance. Here we have put the tolerance, we have taken 43 millimeter K 5. For K 5 plus minus value are there, this can be done. And in dimensioning there are two ways. One is that you simply put that number, because that chart is available, manufacturing engineer he can dictate, or the even a machine man he knows what are the tolerance will be there. And alternatively you can put the plus minus value there itself. Depending on the plus minus value and the surface finish what we have mentioned here. Here what we have done, we have used 3 triangle 0.8. This means that this should be super finished, but not necessarily ground. For grinding this value 0.8 here which we have given, that is called RMS value of surface roughness. Either you can put in this way, alternatively there is another way that you can put something like this and 0.8 everywhere. For example, here also thus where the bearing is coming 0.8, here nothing is coming. So, double dot means it is 3.2 as you see here. So, it is just fine cut, but it is not the super fine cut. Usually for this you may need for grinding this tolerance, but it is also possible with a good finish cut by lathe. Okay. So, next that here probably while the machining will be done, the machine man what he will do, he will look into this diameter. Here it is 53 and here it is 43 and here it is 42. So, probably he will cut this portion 108 or a little less of diameter very close to 43 plus. He will cut this one and then he will gradually finish this and he will reach here. Then he has to look in the other side. Similarly, other side he will cut up to this point. The dimensions are given in that way. And as you find here, there will be a circlip, groove for circlip. If you remember, we have used the circlip there. So, there will be a groove for circlip and that dimensions are separately mentioned somewhere. Say here we have given the D2, one circle and we have written D2. Somewhere we will make the detail D2 and where as specified by the circlip group manufacturer, you have to put the groove accordingly. But one thing you should notice that this end from this end where the bearing will sit, that should be less than actual bearing width, and some tolerances are there. We have taken 17.9 whereas the bearing width is 18, and these grooves are made in such a way that this just it will go inside and really it will be somewhat tight fit, but it is not that dimension should be such that circlip should go inside, otherwise there will be a problem. And after the circlip, this length is usually 3-4 millimeter for this shaft size, we can keep a little more there. So, these are about the dimension of the shafts, and as you find here we have mentioned the pitch circle diameter, but sometimes it is not given here because the gear data will be by the side of that, and on the pitch circle we have put 3 triangle with 0.4, and that means the surface finish of the gear teeth will be of 0.4 micron. Usually it will demand the grinding, but that is just to show this dimension. This gearbox what we have designed, we need not go for grinding, a good hobbing will do. But if you that means this perhaps we can put a little more 0.6, 0.7 micron surface finish will do. And here as you see this corner radius, we have mentioned the corner radius. Another important dimension, if you look into that, this is that here we have put with a triangle, filled in triangle A, and here we have put B, and here we have written an arrow, inclined arrow, then 0.16 and AB. This means that if you consider the cylindricity of A and B and here the pitch circle, that may not be, all the axes may not be perfectly matching. They may be slightly inclined, because when we will cut the gear, then this will be put into other machine, gear cutting machines, hobbing machines. There we have to center it, again we have to cut it, and maybe slightly that table itself have slight misalignment. Also, while we are machining this shaft, these two end may be shifted slightly this way and that way. Here this means that whatever that, say they are making some angle and other things, that means if we consider this center with respect to this center making a circle, some eccentricity, that eccentricity value, it is maybe 0.016 millimeter, it is like that. So, for that there is more details are with the manufacturers. I have just this idea and I am giving this idea to you. Sometimes instead of inclined this one, or along with that there is two circles, one dot, one center and one circle is drawn, and then also some value is there. That means what might be the eccentricity between these two center, just to maintain the cylindricity of these gears. And here as you find that this is a fine thread, we have M 40 into 1.5, and these details also, this group details are not shown here, that is also made separately, detail D1. These are usually, a tool is available, that tool we can put it there and we can cut it. And as you find the tolerances are given, that to be mentioned, but by no means all dimensions we have given here. This is just an sample drawing. Now, here this, if you look into this, we have with this drawing there are notes. The first note is that all corners, edges which are chamfered means this corner are cut, is 1.5 into 45 degree for shaft dia over and including 50 millimeter, and it is 1 into 45 degree for shaft dia below 50 millimeter. So, if it is not mentioned, we can give that chamfer. Usually each manufacturer having their own data for that. So, and one code is there. So, instead of giving that, they put simply the code there with an arrow, with an pointer there, these are given. Okay. So, one can know that what it is, it can finish. So, you can read this note, while this note will be available with you, you can read these what are given. This is only few example, maybe some additive notes are there, as well as there will be note for heat treatment, etc. Now, interestingly, if you look into the keyways, here the keyway is shown. While I was calculating QA, there it is specified what will be the depth of cut on the shaft, but depth of cut on the shaft you cannot measure on the machining. While you are machining, if it is a CNC machines or somewhat, if there is a good measuring device, you can measure during the cutting process, but ultimately you have to measure these dimensions. This is nothing but the depth of cut mentioned there, that minus subtracting from the diameter there, and obviously there will be tolerance also, some tolerances. Of course, on the shaft you have to give some tolerances, that you have to calculate, or you have to consider from the specification, and that you have to give. Similarly, for this locking groove, that is also cut in this way. This mentioned, of course, for locking groove you need not give the tolerances, whatever the locking that it is a, you can say that on projected portion, that dimensions is given, you can make slightly more than that. For that also some special cutter is available, or use a side and face cutter here. With that you can make this group, say 6.5, probably that thickness was 6. So, we have given 6.5, and here it could be 37.5. if you look into that here, that there it is given 37.5 from the bottom to the washer notch, and we have put here 37 millimeter. So, this is a brief idea about how to make the detailed drawing. We have to be very careful, and no dimensions should be repeated. In case you have to repeat just for the confirmations, then you can put, say for example 34 millimeter here, you can see this is this plus this plus this is 34 millimeter, and that we have put as a reference for measuring purpose. Okay. So, that you have to mention. So, I have shown here this right hand side of this for the QA and other things, but that already we have explained, and then this is the left hand side of the pinion part, it is given, and here this gear data is shown. Usually only the gear data for this pinion will do. So, in that way I suggest that you have to better to give that first is gear dimensions along with this pinion dimensions here with this drawing. This will easily, if there is some mistake or something, one can easily understand. Only this pinion dimension will do, but one can provide these two dimensions. No harm if you provide this full chart there for such a small gearbox, but this has to be provided with this drawing along with the notes on heat treatment and other requirements. Okay. Similarly, we can develop the drawing, detailed drawing of the gears. Here I have not shown much dimensions, because only important dimensions are the inside diameter, outside diameter and thickness. Then this corner finish, the chamfer, everything that can be followed from the general rule. However, one important thing is there, even if such small gear, sometimes some materials are removed from here. If it is if it is made in large quantity, then from both sides these materials are removed. Okay. And also you may find there are holes. See, this is a ring sort of things, and there are holes, maybe 4 holes. That helps in mounting the gear while you are machining. Okay. And of course, the material will be less. Suppose if you go for forging, you can rough forging can be done with that, and then machine finish can be done on that. And importantly, for this key groove, here it will be made by slotting, that means it will be through from this side to this side, and we have to mention from the bottom to the top of this, but this we may not need tolerances, because there will be some clearances. So, whatever the depth of cut is suggested, say T2 on the chart, if you look into the key table and then add that one with the shaft diameter and put that value here, and this width is 12, that is of course needs some tolerances. Okay. Also the gear data we have provided here, and this is the end of detailed drawing. Thank you. And I would like to mention here that detailed, while you are making detailed drawing, each and every component you have make a detailed drawing. Okay. So, I have shown only the sample of the one shaft with integral pinion. I think following that you can develop also the detailed drawing of input gear, and following the first stage gear drawing you can easily develop the second stage gear. Then of course, housing you have to, each and every point you have to consider, and then while making the detailed drawing of that you have to make on the shaft what you have done. Of course, one thing is there that we are locking the bearing only at one side. So, other side is free. So, while we are thinking of the width, it is not that important. So, bearing may be slightly inside the box or inside the bearing mounting, it may not affect much, will not affect much for such design. Okay, thank you.